Hello and welcome back, my aspiring statistician or fellow stats enthusiast. I'm delighted you decided to join me again. For those joining me for the first time, my name is Bronwyn and I'm a lecturer at CPUT. And in the previous screencast, we had spoken a bit about why we need statistics or why we use statistics, the two branches of statistics, namely inferential statistics and descriptive statistics. And then we touched on populations and samples ethics, and we were about to discuss data, which leads us to this screencast number 2. Please know I welcome all feedback to my screencast, and if you want to contact me, you're welcome to do so at swatsb@cput.ac.za, and then also know that you can download this clip and watch it as many times as you want to. Please share it with your friends if you want to, and tell them about us and what we're doing at CPUT. Okay, so let's start with the fun stuff. Data, as we were saying. Now, data we can broadly categorize into two types. The one type is primary data, and primary data refers to data that we collected ourselves. Now, the disadvantage of primary data is it can be expensive. Ask postgrad students, or not even postgrad students, ask anyone that must collect their own data. Most of the time it's going to be time consuming at the very least, and sometimes it can be expensive too. But the significant advantage of collecting your own data is you're going to collect exactly the data that you need to conduct your study or to solve the problem that you have. Typically, you would use statistics or you'd use these techniques, you do research and you collect data because you have a problem and you have a question that you want answered, whether it's for a research project or whether it's also just at work or maybe it's even a domestic situation. Now, sometimes we're in a fortunate position where we can get secondary data. And so that's data that we borrow. Someone else has collected it and we're using it. Either or, whether it's primary data or secondary data that you're going to be using for your statistics, the typical ways that we would collect the data would either be through observations or surveys or experiments. Now, the type of or the manner in which you collect the data will generally dictate the kind of data that you will collect. So, whether it's primary data or whether it's secondary data, that data can be classified as either qualitative data or quantitative data. Now, to distinguish between qualitative data and quantitative data, qualitative data is typically textual data. It doesn't need to only be text though. Qualitative data can also be pictures or videos and even audio, and that is data that we don't need to convert into numbers to analyze the data. But the moment that we convert data into numbers, then it becomes quantitative data, and that's the stuff that we statisticians are interested in. So quantitative data uses numerical values to describe the variable that is of interest to us. And now we take it a step further. If we have quantitative data, we can categorize those even further into 4 data types depending on the measurement scale or the way that we measure the quantitative data. And so the first kind of quantitative data that I'd like to tell you about is nominal data. Now, this is the starting point of quantitative data because this data can only be separated into categories, discrete categories, or labels. It's also known as categorical data. It has got qualitative categories, or I beg your pardon, qualitative characteristics. But because we count it, it is quantitative. But we cannot use numbers to distinguish between it. The only thing that we can do is we can count it. So examples of nominal data would be male or female, for example. Another example I have there is yes or no labels. And we could even slip another one in there. It could be yes, no, or maybe. And then instead of 2 categories, we'd have 3 categories. Another example is red, blue, yellow, or green. I think we all get the idea there. And this type of data is used for descriptive statistics. It's typically used for descriptive statistics. It can be used for inferential statistics, but then you're going to need a lot of this kind of data to be able to use it for inferential statistics. But it generally is used to describe what you're seeing happening in a population based on the sample that you've collected. We progress a little bit further, and the next type of data is ordinal data. This is also quantitative data with qualitative characteristics because we've divided the data into labels. But the thing that we can do with this data is we can rank it, or basically we can place it in order. And this is now known as discrete data. So we have the labels, it could be yes or no or maybe, but we can place it in an order that is logical and that makes sense. Or another example, as you can see on the PowerPoint slide, a hotel rating. It could be a movie rating as well. And what we can't do, however, is we can't numerically perform operations on this data, because even though we have a ranking, we don't know for sure if for example we say a movie is a 1-star movie or a hotel is a 1-star hotel, we don't know that if we obtain information to say that another movie is 4 stars, that it is 4 times better than the 1-star movie. That also depends on the person that you ask, because that once again is subjective, we all understand. But what we can do is we know that the one is certainly higher or better or lower, if lower is the case, for sure than the other one. But we cannot mathematically say that the amount, the interval between them is precisely 4 times higher or 4 times lower, if that is the case. And so this takes us, as we progress a little bit further away from this, to the next 2 types of quantitative data, which we now start referring to as continuous data. The next type of data is interval data. So interval data is where we start using numbers to measure the intervals between the data. The interval data specifically, however, does not have a true zero. So what we can measure with interval data is the intervals between data points. We are certain of the difference measured between 2 data points or observations, but because we don't have a true zero, even though we can subtract and we can add the distance or the difference between 2 data points or observation, we cannot multiply or divide. We don't know if twice the amount is necessarily twice as much. Even though this is also a form of continuous data, and the next type of data that we're going to discuss is also continuous data. An example to try and illustrate what I mean is the temperature of something. We know that 180 degrees is always 10 degrees more than 170 degrees. And we know that the distance, or not the distance, the difference between 5 degrees and 15 degrees, that interval is the same as the interval between 180 degrees and 170 degrees. However, if you want to bake a cake, which is supposed to be baked at 180 degrees, and it's supposed to be in for 20 minutes, if you're going to bake it at 360 degrees, you're not going to be able to bake it at half the time, or 10 minutes. And so as we progress from there, the next type of data that we're going to discuss, which gets all statisticians really excited, is ratio data. Ratio data is considered to be the king of king for statistical purposes. Not only can we add and subtract this data, we can also multiply this data. The distinction between ratio data and interval data is a very fine line, but what we can say is twice as much is really twice as much. And examples of that is age or meters, anything that's measured, we can subtract, we can add, and we can multiply and divide, because this data has got true zero. In the absence of anything, there really is nothing. So a nice tool that we can use to try and distinguish between the different data types is this table. As you can see in this table, there are 4 questions. And if we ask ourselves these questions, the answer to the questions will tell us what one of the 4 types of quantitative data we have at the moment, if we have data in front of us. So if we have data, and the first question we ask ourselves is, are we able to put the data into categories? We'd be able to say yes for all of them, whether it's nominal data, ordinal data, interval, or ratio data. Then we ask ourselves the next question, are we able to arrange the data in order? If the data is nominal data, the answer to that question would be no. But if it's any of the other 3 quantitative data types, the answer would be yes. We can then ask the next question, which is, are we able to subtract the data values? Of course, we'd already know that it's not nominal data at that point, but if it's ordinal data, we then say answer no, and we know that the data that we're sitting with is either interval data or ratio data. And the final question we ask is, are we able to determine if one data variable is a multiple of the other? Of another? And if the answer is no, in that case we know it's not interval data and it must be ratio data. So through a process of elimination, we can decide what type of quantitative data it is that we are using if we aren't quite sure about it when we first see it. And so this is a nice way to also illustrate the way that the relationship between the 4 types of quantitative data. If we put them on a scale or a continuum, we would say that nominal data would be on the one end. So this is data types, quantitative data types, and then from nominal data we can progress to ordinal data, and this is information. This continuum illustrates the amount of information the data is giving us. So on this side would be little information, and on this side would be more information. And so if we have nominal data, it just tells us the categories. If we have a little bit more information, if we have a order or a ranking scale, then it would be ordinal data. If we have a little bit more information, these 2 data types are considered to be continuous. And the 2 types of continuous data would be interval and ratio. So I think this is a nice logical place where we can finish the screencast. Thank you so much for joining me again, and I'll be looking forward to chatting a bit more about my favorite topic or one of my favorite topics in the next screencast.